Is it recording? I don't think it's recording yet. How do I do this? Okay. Okay, I think it's recording now. Okay, yeah. Hello guys. Today we're gonna be doing the lesson 1. It's a generational thing. So go ahead and flip on over to page 501, and we're gonna be learning about exponents, bases, powers. Okay, so make sure you write down everything that's in black already written on here, as well as whatever I'm going to be talking about and writing. So it says base is the expression that is used as a factor in the repeated multiplication. Exponent is the number of times that the base is used as a factor in the repeated multiplication. So number 1, how do I scroll over? It's not letting me. Okay, there we go. Number 1 says identify the base and exponent in each, then write each power as a product. Finally, evaluate the power. So the base is going to be your 5. So base is 5. And then the exponent is the little number on the top right corner, which is this 3 right here. And let me actually delete that. That way you can see it. So the exponent tells me how many of the bases I have. So that means that I'm going to have 5 times 5 times 5. And then lastly, they wanted to evaluate the power. So 5 times 5 times 5 is 125. So that's what it's going to be. Then for this, for part B, anytime you have parentheses is very important because you have to keep it as a parentheses. So this means that my base here is -9, and the exponent is 5. So that means that I have 5 of the -9s, and I have to keep it as an exponent. So -9 times -9 times -9 times -9, 1, 2, 3, 4, one more time, times -9. What does that give me? Put it in the calculator. Let me see if mine works because I think it's not charged. So yeah, it's not charged. Hold on just a second. I'm gonna do it real quick. You know what? I'm gonna show you how to do it on Desmos. Okay. I'm gonna pull up Desmos, graphing calculator, and then we had -9, and then -9 again, -9 5 times. So that's 4. One more time. So we get that big number. Okay. Negative. So 1, 2, 3, 4, 5. Yes, I did that right. Negative 59,049. Where is it? Right here. Negative 59,049. So that's my answer. All right. So whenever you don't have parentheses around the number, then you just write it like that. So like, for example, for part C, the base is 11, okay? And the exponent is 3. So that means since I don't have parentheses like how I had up here, that means that this is just negative, and then 11 times 11 times 11. Okay, you don't write down the negative sign 3 times like how we did in part B because it doesn't have parentheses around. So it's a little bit different. The parentheses is really important. So make sure that you always write down, like if it doesn't have the parentheses like how I did here, you always write down the negative sign first, and then your base was 11 because it doesn't have parentheses around it, right? So that means it's 11 times 11 times 11. So you only have the negative sign at the front one time. I hope that makes sense. So now you put it in the calculator so you can put down the negative sign, and then you have 11 times 11 times 11, which gives you negative 1,331. Whoops. Negative 1,331, and that's your answer. All right, now for this one, let me change the color. Let's do black. What is my base here? Well, let's look at this one first. My base for the 4 is just 4, right? And then the exponent here is 5. I read that wrong. The exponent is 5. And then for this one right here, for the second set of parentheses, my base is 3 and my exponent is 6. So that means that I'm going to have 4 of the 5s. I'm going to have 5 of the 4s. So this is what that looks like. 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. I have it 5 times, right? Because my exponent was 5. And then let me change the color so y'all can see the difference. Now for the second set of parentheses, my exponent was 6 and then my base was 3. So that means that I'm going to have 6 of the 3. So 1, 2, 3, 4, 5, 6. Okay, so I hope you're starting to see like a pattern that we're doing here. So you're gonna put this whole thing in the Desmos. So how many did I have of the 4s? 5. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. Did I do that right? I forgot my multiplication sign right there. 1, 2, 3, 4, 5, 6. Yes, and let me delete this. So we get that big old number. 746,496. What was it? 496. Okay. Okay. So hopefully that gives you an idea of what the exponent is. Like I said, the main thing here, parentheses, is very important. All right, moving on. Oh, how do I scroll? Here we go. Write each as a product, then calculate the product. So same thing. I wrote a little example here. So for example, if you have that little caret sign that's like that, that means this means -5 to the power of 2. Okay, that's what that caret means. That caret means it's an exponent. I just couldn't figure out how to put it as that in the application that I was using, but that's what that means. All right, so let's go ahead and get started. Right here for part A, we don't have parentheses around it, so that means that I'm just going to write it as negative first, right? Then my base is just 1, not -1, is just 1 because there's no parentheses around it. So I already wrote down my negative. Now I just write down 1 times 1 because my exponent was 2. What's -1 times 1? That's -1. So this is my answer. For B, we have, again, no parentheses. So that means that my base is just +1, not -1. So I write down the negative first, and my base is this right here because there's no parentheses. So that means I write it down 3 times. 1 times 1 times 1. What's -1 times, or the negative sign times 1 times 1 times 1? But that's just -1 again. And then -1 to the power of 4. So again, negative sign. My base is 1. 1, 2, 3, 4. This gives me -1. And you get the point, right? You can do D by yourself. I'll let you do D by yourself. All right. So for part E, now we have parentheses around. So that means that the exponent corresponds to everything that is inside of that parentheses. So my base here is -1, okay, because of the parentheses. So that means that I have 2 of the -1. So I'm going to write down -1 times -1. Negative times a negative gives me a positive, and 1 times 1 is 1. So my answer is just 1. For F, same thing. I have parentheses around the whole thing. So that means, and the negative is inside of the parentheses. Therefore, that means that I have 3 of the -1s. So -1 times -1 times -1. Put this in the calculator and you should get -1. Now for G, let me change the color real quick. Same thing. I have parentheses around the negative and the 1. That means that my base is that whole thing that's inside of the parentheses. So I have -1 times -1 times -1 times -1. And that should give me +1. And then I'll let you do H by yourself. All right, I'm going to try to move on quicker because I'm not trying to make the video too long. All right, go to page 504. All right, it says rewrite each expression as a product using expanded notation. Then identify the base or bases and record the number of times the base is used as a factor. All right. So rewrite the base as many times as the exponent says and count how many you have. So again, the little caret thing right here, that just means to the power of. So really, this is 5 to the power of 3. Okay, and then 5 to the power of 4. So same thing as we were doing, the base here is 2. I'm going to do this one first. So the base here is 2, and I have an exponent of 4. So I'm going to have the 2 4 times. So 2 times 2 times 2 times 2. Now I'm going to go ahead and do the other one. So 2 to the power of 3. So I have the 2 3 times. So 1, 2, 3. Put it in the calculator and let me know what you get. Okay. We're not going to spend time doing that. You can do that one on your own, right? So now the base is 2, and I want you to count how many 2's you have. 1, 2, 3, 4, 5, 6, 7. So that is to the power of 7. That's how many you have. You have you have 7 of the 2's. So this is actually the proper way of rewriting it, okay? Now let's go ahead and do B. So this one we have parentheses. That means I'm going to do this at first. That means that my base is -3. So -3 times -3 times -3. And then I'm going to do this side now. Same thing. I have it 3 times. Yeah. So -3 times -3 times -3. So my base was -3. And we're going to put this in parentheses. How many did I have? 1, 2, 3, 4, 5, 6. I hope you're starting to see a pattern here. If not, that's okay. I'll reveal the secret at the end, okay? All right. Part C. This 4 right here, it doesn't have an exponent, so it's an imaginary 1 right here, right? If it doesn't have an exponent, it's an invisible 1. So that means that I'm just going to rewrite it one time. So I took care of that one. Now let's go ahead and take care of this one. So this one is 4 to the power of 5. And the exponent is inside of the parentheses. So that means that I have 5 of the 4. Sorry. Yeah, no, I was saying it right. Sorry. We have 5 of the 4s. So I have 1, 2, 3, 4, 5. Now count how many you have in total. 1, 2, 3, 4, 5, 6. My base was 4, and then to the power of 6 because that's how many I had. All right, moving on. So this one, the exponent is on the inside of the parentheses. It's the same thing, okay? Yeah, it's the same thing. So that just means that I have 2 of the 5s. So that means that my base here is 5 and I have 2. Now I do this one, 2 of the 6s. Now I do this one. Now I have 3 5s. So 1, 2, 3. And then I have 1 of the 6. Okay, now for this one, you only want to combine the bases that are the same. So right here, I have 5 and 6. That means that I'm going to take care of the 5 first. Let's count how many of the 5s I have first. I have 1, 2, 3, 4, 5. So this is 5 to the power of 5. Okay. Now I can go ahead and do the 6. You cannot combine these because they're different numbers, okay? So you can only do it whenever they're the same. So I have 1, 2, 3 of the 6's. So this is 6 to the power of 3. You can also rewrite this as 5 to the power of 5 and then 6 to the power of 3 if you would like. It's the same thing. Okay, so that's how you do that. Hopefully, for this next one, I'm going to reveal the secret. Hopefully, you've already figured it out yourself, but if not, that's okay. So, if you notice here, my base, I'm going to take care of the 9s first. So, this is 1 9, and I have the other one right here. Okay, so I have my base of 9. Now, look at the exponent. I'm going to be adding them. 3 plus 2 is 5. And I'll show you, that's what I was doing this whole time, okay? Let me show you real quick. Let me erase some of these circles. So right here, my base was 2. I'm looking at part A right now. My base was 2. My exponent was 4, and this one was 3. So if I add 4 plus 3, that gives me 7, and that's what I got, right? So that way, if you don't want to do all of this work and write it all out, because that's a lot of work, especially if you get really big exponent, you can just add the exponents. Anytime you multiply, we call this the product rule of exponents. Okay, anytime they're multiplying, you add the exponents. Okay, so when multiplying, add exponents. So there you go. I'm not going to write down the 9 that many times, but I showed you the trick, and that's what I'm going to be doing, okay? So my exponent for the base of 9 was 3 and 2, so I added them up, 9 to the power of 5. Now I'm going to do the 4. So 4 here was 2, and then here was 5. 2 plus 5 is 7. And then this is what you get. And then I'm letting you guys go ahead and put this in decimals and see what big number that gets you, okay? But I'm trying to make this video short, so I'm not going to do that. All right, go to page 505. And right here, if you want to look at the worked out example, it says the exponential expression 4 to the power of 2 and then to the power of 3 is a power to a power. Anytime you have a power on the inside and then an exponent also on the outside, you have to rewrite it like this. So for example, here, anything that's inside of the parentheses means that, well, depending on what the exponent that you have, like right here on the outside, we have a 3. That means that everything that's inside of the parentheses is going to be on there 3 times. So I have 4 to the power of 2, 1, 2, 3 times. Okay, and you can rewrite this. You can even expand this even more. What's the base here? 4, right? And I have 2 of the 4s, so 1, 2. That's this one. Now I have it one more time, right? They expanded it. That's this one. And then one last time. That's this one. So you can expand even more on that. Okay, whoops. So let's go ahead and see some examples if that didn't make sense, but hopefully it did. How do I scroll? Okay, here we go. So use the definition of a power to write repeated multiplication expressions. So right here, my base is this whole thing, 8 to the power of 2. My base is this whole thing, right? And then I have the exponent of 3. So my exponent is 3. So that means that I have 8 to the 2, and I have to keep my parentheses, 8 to the 2, and 8 to the 2 3 times. I can expand this even more, right? Because how many 8s do I have here? 2 of them. So let's go ahead and do that. 8 times 8. Now let's do this one. How many? 2. 8 times 8. How many here? Look at the exponent. 2, 8, and 8. Put this in the calculator and see what that gives you. Now, let's see how many do we have. Let's count them. I have, my base was 8. I have 1, 2, 3, 4, 5, 6. So 8 to the power of 6. And put that in the calculator and see if you get an answer, or see what answer you get. Same thing for B. Everything that's inside of the parentheses means that I'm going to have 2 of them because of that exponent on the outside. So I have 5 to the power of 4, 5 to the power of 4 twice. So now my base here is 5. And how many of the 5s do I have inside of this parentheses here? Well, look at the exponent, 4. So I can rewrite this as 5 times 5 times 5 times 5. Same thing here. My base is 5. How many do I have? Look at the exponent, 4. So write it out again. 1, 2, 3, 4. Now you can count them all. My base was 5. I have 1, 2, 3, 4, 5, 6, 7, 8. Okay? All right. So now here's a trick to this. I'm gonna go ahead and tell you guys a trick to this. Whenever you have a parenthesis, anytime you have a parenthesis, that means that you're gonna have well, not always, but sometimes you're gonna have an exponent on the inside and the outside. So what you can do, instead of writing all of this out, you can just multiply. Whenever you have 2 exponents, like one inside of the parentheses, like here, and one on the outside, you multiply. 4 times 2 is 8. And look, that's what I got right here. Right here, I had 2 on the inside, 3 on the outside. 2 times 3 is 6. And look, that's what I got, right? So you keep your base and you multiply the exponents. That's whenever you have 2 exponents. That's like if you have an exponent on the inside of the parentheses and one on the outside. Okay? All right, so let's move on to C. So right here, I have my negative sign. Notice how the negative sign is outside of the parentheses. So it's just a negative sign on the outside. And then this is 6 to the power of 1. So on the inside, I have a 1. On the outside, I have a 6. What's 1 times 6? 6, right? And my base here was 6. So this is really 6 to the power of 6. And this is my answer. All right. So now for part D. Now this one is a little bit more tricky because you have 2 parentheses. So you really have to be careful on how you separate it. So you have, let's look at the inside, at the very inside first. So we have negative 6 to the power of 2, and that negative 6 is inside of the parentheses. So that means that we have it twice. So negative 6 times negative 6. Okay. And then hold on, guys. Can you tell me in a little bit? I'm making a video. Okay. All right. So now, sorry, guys, I lost my train of thought. Where was I? Yeah. So I had this like this, negative 6 to the power of 2, and then negative 6 to the power of 2 because this whole thing is inside of this whole thing, right? So now I can rewrite this again. So I have negative 6 times negative 6, and then I have to take care of this one, negative 6 times negative 6. So now count them. My base is negative 6, and count them. I have 4 of them. So negative 6 to the power of 4. Okay. And then actually I made a little mistake because we have parentheses. I forgot my parentheses. Make sure all of that it's in parentheses, okay? Parentheses is really important here. So that's what you do whenever you have an exponent on the inside and the outside of the parentheses. All right, so now we're going to get to whenever we're dividing. So it says, same as we did for the previous examples, but now for dividing. So this is, make sure you write down everything that's in black. It's a little example right there. But I'm going to go ahead and just move on. So write each numerator and denominator, write each numerator and denominator as the product. So we're going to look at the top. We're going to look at the numerator. Okay. I have 1, 2, 3, 4, 5. Over the bottom, the denominator, right? 9 and 9 because of the 9 to the power of 2. So now that you do that, it says that they want us to simplify each expression and write the simplified expression using exponents. So what they mean by simplifying is that you can cancel these out. Well, they don't technically cancel out, but they reduce to an invisible one. 9 divided by 1 is 1, but it just becomes invisible. Oh my goodness. I'm like talking too fast. I need to slow down. All right. So that's 1. And then also I can do it one more time right here. So now you're left with the top. How many do you have? You have 3. So this is 9 to the power of 3. Okay. Whenever you're left with some at the top, it's you don't have a fraction. You're just left with 9 over 3. But 9 to the power of 3. But if it was in the bottom, then you would have a fraction. And let's see if we get one in these examples. So let's do B. You have 5 to the power of 6. So write down the 5 6 times. 1, 2, 3, 4, 5, 6. And then 1, 2, 3. Cancel them out. You're left with 3. Hopefully you guys are starting to see a little pattern here. If not, I'll reveal it at the end. Oh, you know what? I'm going to reveal it right now because I don't feel like writing down 8 of the 10s, okay? So I'm going to tell you guys. Whenever you're dividing, this is called the quotient rule, okay? Quotient rule. Whoops, quotient rule. So when dividing, subtract the exponents. Okay. So just like how we did when multiplying, we were adding them. Whenever you're dividing, you subtract them. So I have, like for example, here I had a 5. And right here I had a 2. 5 minus 2 was 3. And look, that's what I got, right? 6 minus 3 is 3. And look, that's what I got. So here, instead of writing down all those 10s, I'm going to go ahead and use the rule. So I have 8 and 6. My base is 10, right? 8 minus 6 is 2. So this is my answer. You always subtract the top minus the bottom, okay? And then right here, I don't have an exponent here. So remember, it's an invisible 1. So my base here is 10. And then I have 2 and a 1. 2 minus 1 is just 1. So I can just leave it like this. Or if you really want to, you could do 10 to the power of 1. Okay. All right. So moving on. Okay. All right. Bye. Okay, moving on. Let's see. All right, moving on to number 4. So it says simplify each expression using the rule that you wrote for a quotient of powers. So that's the rule that I was just talking about, okay? We're not going to go ahead and write all of these like 8 times. So let's just go ahead and use the rule. The base here is 6. My exponent at the top is 8. The bottom is 3. 8 minus 3 is 5. So that's my answer. Right here, I have a negative, so write down your negative. My base is 9. 7 minus 5, 2. And I have no exponent, right? So I just keep it. Sorry, no exponent. I have no parentheses, so I just keep it without the parentheses. But if you were to have a parentheses, then that would be important. Right here, I have, let's see, 2 over 3. I have different bases. This one you cannot simplify. You cannot simplify this because you don't have common bases. You have a 2 and a 3. They're not the same. Right here we had 9 and 9, and we had 6 and 6. So that's why we were able to just do this. But for this one, we're just going to keep it like that. and just put this in the calculator, and you should get an exact answer, like an exact number. So it's going to give you a number. So actually, let's go ahead and do that one. So you're going to have 2 to the power of 3 over 3 to the power of, what was it? 2. Oh, where is it? And you get that. You get a decimal. So that would be your answer. Here you can't do the trick because you have to have common bases. All right, moving on. So moving on to page 510. Rewrite each expression, each sequence of numbers using the definition of powers. I think for this one, let me see something real quick. We're not going to do that. We're going to do, rewrite each, were we supposed to do this one? No, we weren't. We're going to do this one, number 7. Using the quotient rule from page 507, okay? So simplify each expression using the quotient rules of powers. Then write each as a decimal. So anytime you have anything to the power of 0, anything, I want you to write this down, anything to the power of 0 is 1. Okay, so 10 to the power of 0, that's just 1 over 10 to the power of 3. And we can't simplify this, so you just put it in a calculator like that. So 1 over 10 to the power of 3, and you get that decimal, 0.001. So there's going to be a 0.001. Same thing here. Whoops. 10 to the power of 0, just 1, right? 10 to the power of 5. You can't simplify that. So again, just put it in the calculator and get the decimal. Same thing here. 10 to the power of 0 is just 1. So just 1 over 10 to the power of 4, because you can't simplify that. You're going to get a decimal. All right. And then right here, we're not going to do this, but that's just to give you an idea of what it looks like as a fraction and as a decimal. All right. So now we're going to get to whenever we have negatives. So y'all are not too fond of negatives, right? But that's okay because it's nothing complicated. So go to page 511, and it says rewrite the power so that the exponent is positive. So anytime you have a whole number, you can make it as a fraction. Like if I have 8, I can make this a fraction by putting over 1, right? So that's what we're going to do. We're going to put over 1. And the easy thing about this is that whenever you're trying to go from negative to positive, all you have to do is just flip it. So the 1 is going to come to the top, and the 8 over negative 4 is going to come to the bottom. But now the negative is going to actually just be positive. So this would be my answer. Well, that's how you would rewrite it as a positive. Then if you want the actual answer, put it in the calculator and see what you get. So I'll let you do that if you want to. So again, right here, put a 1 over it. Let's flip it. 1 over 5 over 6. And that's how you make it a positive. If you want to find the decimal, go ahead and do that. Same thing here, over 1. So this becomes 1 over 7 to the power of 5. And then here, you have to do these one by one, right? So this is 4 over 1. Then this becomes 1 over 4 to the power of 2. And then over 1 over here, this becomes 1 over 3 to the power of 3. So my answer would be 1 over 4 to the power of 2 times 1 over 3 to the power of 3, like this. Or you can put parentheses around it for this one. It doesn't matter because we don't have any negatives anymore, so the parentheses isn't as important. The parentheses is only like super important whenever you have negatives. And if you would like to do some extra practice, you can do this. But for the sake of this video not being too long, we're not going to do that. All right. So for this one, this is just practice for you. Look over pages 504, 505, 507. So we're going to do a couple of them because we do have letters here. And I know we didn't do any with letters. So whenever you have letters, it's the same thing. What's my base here? So the base is the number that's attached to the exponent. Here it's 8 and here is 6, right? So my base here is A and A. My base is A. My exponent, I have two different ones, so I'm not going to write that down. Because, well, actually, you know what? We can. Exponent, 8 and 6. So my base is 8. Then I have 8 plus 6 because this is my my product rule. Remember, whenever you multiply, you add the exponents. So then I add them. 8 plus 6 should give me 14. Okay, and then now what do I do with the 2's? Well, the 2's don't have an exponent. So you just multiply. What's 2 times 2? 4. So there's my answer right here. Okay. So anytime you don't have parentheses and the exponent is with the variable and not with the numbers, you just multiply, like right here, 4 times 8. 4 times 8 is 32. My base is B, and then add them. 2 and 9 is 11. So this would be my answer. Okay. And then right here, I don't have any parentheses, so I can go ahead and just multiply all these numbers, all these coefficients, right? So -3 times 5 times 2, that gives me, what -3 times 5 is -15 times 2, -30. And then my base is C. How many C's do I have? Well, let's see. Right here, C to the power of 1, because there is no exponent, so remember, it's always a 1. And then I have 3 and 9. So 1 plus 3 is 4, plus 9 is what? 13, right? So C to the power of 13. Now, whenever you have parentheses, it's different because now you have to, that means that you have, the number also is going to have an exponent. If there's no number, if there's no exponent inside of this number, it's an invisible 1, right? So my base here would be 3, and then I have 1 times 3. So you always do the inside times the outside of the parentheses. So this is to the power of 3. And then now I do it for D. 2 times 3 is 6. So this is what I would get. Well, actually, you would simplify this even more. 3 to the power of 3, put it in decimals, 27. So my final answer here would be 27 D to the power of 6. Okay. Now let's go ahead and do the other ones. So again, you have parentheses. So whenever you have parentheses and you have a coefficient there, that means that the exponent here, since they didn't specify, is just an invisible 1 right here. So I have 10. Then I have 1 times 5 is 5. For E, doesn't have any exponents, so again, it's a 1. So E, I have, again, 1 times 5 is 5. And then for F, they wrote down, let me erase this because it's getting kind of hard to see it. For F, I have 3 on the inside, 3 as the exponent on the inside, and then 5. 3 times 5 is 15. So 10 to the power of 5, let's put that. 10 to the power of 5 is 100,000. So 100,000, E to the power of 5, F to the power of 15. This is my answer. Now let's do some whenever is division or a quotient. We call this a quotient rule. So I have my same basis, F. So F, and then you do 8 minus 3 because whenever you're dividing, you subtract. So 8 minus 3 is 5. Then whenever you have coefficients, just like how we did up here, You know, like how we did up here, whenever we didn't have, let me erase some of this stuff. Whenever we didn't have an exponent, whenever we didn't have a parentheses, we just multiply them, right? Because they're being multiplied. We got 32 there. Here, 2 times 2 is 4. That's whenever you don't have parentheses. Same thing here. What's 10 divided by 5? 10 divided by 5 is 2. And then your base is G. And then 4 minus 6. Remember, you do top minus bottom. 4 minus 6 is negative 2. And then to rewrite this, well, you have to flip it, right? So you have to put the G over the 1. So you have 2 at the top still, but then you're going to have times 1, because that 1 is going to flip to the top and the G is going to come to the bottom, and then you're going to have G to the power of 2. 2 times 1 is just 2, so this is actually 2 over G to the power of 2. Anytime you have a number right here, that number is going to stay at the top, okay? That number is always going to stay at the top. That one doesn't flip. Only the base flips. All right. Let's see. 30 divided by 15, that's 2. My base is H. 8 minus 2 is 6. So this is my answer. Or that whole thing is my answer. 35 divided by 7 is 5. Now right here you have two variables. It's the same thing. You do I with I, J with J. So I is 7 minus 2, which is 5. And then for J is 3 minus 3, which is 0. And then remember, anything to the power of 0 is 1. So really, this is 5i to the power of 5 times 1. Or anything times 1 is just whatever that thing was. So this is really just 5i. Wait, I wrote my I wrong. Whoops. 5i to the power of 5. Okay. And then this one, super easy. This whole thing is in parentheses and it's to the power of 0. So this is just 1, because anything to the power of 0 is 1, right? So hopefully that video made sense. I hope you guys enjoyed this lesson. If not, then you can just email me at Ms. Jimenez and we'll try to help you guys out. Whoops. My computer needs an update. All right. So that's it for today's lesson. Y'all have a good day. Bye.